Hi everyone, myself Sai Tarun. Here are my teammates Nitin and Vikas, and the language which we chose to design for this project is named Striger. The reason we have given this name is because we initially thought of designing only for string and integer, but later on we have added boolean values as well. These are the core features of a striker. It supports data types such as integer, string, and boolean. It supports two types of printing of variables like print of variable with parentheses and print of variable without any parentheses. It has two types of conditional statements. One is if condition. It has in this if condition it has also else elif part along with else part, and then if then else condition. It is also similar to above one, but here there won't be any elif part. It has three types of loops: for loop, while loop, and for in range. And here it supports basic arithmetic operations such as addition, subtraction, multiplication, and division. The boolean operation it supports a true, false, and not, and less than, and greater than, and etc. The variables the variable's name must contain small and capital letters along with numbers, but the variable name shouldn't start with any number. The main components of Striker program are initialization, computation, and conclusion. Initialization. Here we assign a value to a variable of a given type. Like for integer values, we assign integer types. Next, computation. This is a main part of program where we manipulate the values as per the requirements. We do this mainly by using conditions and loops. Conditions, as the name implies, here if either of the conditions are met, then we evaluate that part. And loops. This is a type of condition such that it executes a set of statements repeatedly until the condition fails. And finally, the last one is conclusion. Here we just display the result of our program to know whether we have achieved a valid output or not. Now this is a grammar of program. We designed it using Antler. We use Antler because it contains inbuilt parsers, lexer, and parse tree. It's also easy conversion from easy to use and easy to write actually. Now I hand over my teammate Vikas to explain about the code, main code and interpreter. Vikas.
Hello, I'm Vikas. Today I'll be going through different files in the programming language Striker. This is Striker interpreter. This takes the parse tree generated from the grammar and gives functions to the rules in the grammar. Like there are functions for each rule. The rules in this grammar are this line, program, initialization, and so on. For these, we have visit program, visit initializations, and visit initialization. All these functions define the functionality of the grammar. If, for example, we go to the rule conclusion and print statement. Conclusion has two functionalities. It is print statement or a semicolon. Now, the visit conclusion function in the interpreter code consists of visiting children, and the visit print statement in the interpreter code maps to the functionality of this rule print statement. There are different types of functionalities for the print statement rule. Like there is print variable name in brackets, print string, print integer, and print boolean expression. Now, this function it defines all those functionalities. If child count is equal to, and so on. Next, we have main.java file. Excuse me. This Java file helps get the parse tree from the grammar. For example, the parse tree generated for the print statement is print string is this one. Now, string Striger main.java file takes this parse tree generated by the grammar and passes it to the interpreter code by calling on it in these two lines. Now, I'll be passing on the test cases and testing part to my friend Nitin. Thank you.
Yep. Yes. Sample code. ఓకే సారీ అన్మ్యూట్ చేయలేనా నేను అన్మ్యూట్ చేసి ఉంచినారా
నాది కాదు నువ్వు అన్మ్యూట్ చేసుకో నన్ను కాదు నువ్వు అన్మ్యూట్ చేయి
ఓకే
so the sample code we have pasted here is the first test case we have tried to execute on our programming language to see if the functionalities are working. So the first test case includes an if statement with an elif and an else statement. So here we initialize the variable x with 5, y with 20 and z with 0. So once in the if statement the condition comes out to be false, so it is going to be skipped, and then the elif statement is also skipped because the condition is also false, and then the else statement is executed assigning the variable z with the value 21. So when we print z, the value 21 is given. Moving on to the next slide, we also generated a parse tree for the test case, and this is the snippet of that parse tree. Moving on, we have also attached a snippet of the output where when we run the test case, we get the output to be 21. So to run the test case, we are using the command java -jar with the jar file, and then the file name with the strA extension. So this allows us to run different files in our programming language. So moving on, we've written several other test cases, and the second test case we've written is the one where we try to check the arithmetic operators and the ternary operator. So we assign the value x to we assign the value 5 to the variable x and 20 to the variable y, and z is computed using the x into y minus y plus x, which will be evaluated to 85, and then the value the variable w is assigned the value 2 because the condition is false, so it is assigned the value 2. When we run the same test case, we get the same 85 and 2. Moving on, we are to the third test case. We have tested this with the loops. As Tarun said, we have 3 different loops: for in range and then while loop. So we try to test all 3 of them. Initializing x with the value 2, we try to print the values from 0 to 5 in a for loop. So the output should give the values 0 from 0 to 4, and then the for in range we try to print the values from 2 to 5, so the output should give the values 2 to 5, and then the while loop where we try to print the value of j from 0 to 7, so it prints the value 0 to 7, and finally the variable x where we try to show that the for loop is working correctly, because once the variable is out of the for loop, it takes the value 5 before coming out, so once we print at the end we get the value 5. Now we can see run the code and see that for the for loop, we as expected we are getting 0 to 4, and in the for in range we are getting 2, 3, 4, 5, and for the while loop we are getting 0 to 6, and then the variable x is given the value 5 after exiting the for loop. Okay. Moving on, we have our next test case where we try to check the syntactic sugar of the programming language. We have included that in our programming language as well. So what we tried is we've given a while loop where we have decremented the value of x from I think from the value 25, and therefore the output should print all the values from 25 to 5, and then after reaching the value 0 it should not print the value 0, but we've added an additional statement at the end to check if the value is given the value of x is 0 or not. So when we run this, we get the output 25, 20, 15, 10, 5, and then the last statement print x gives 0. Moving on, we've also tried to implement real life problems. So this is an implementation of a binary search algorithm. You can see that the lowest value x is given 0 and y is given 10. Z is initialized to 0, and we want to search for the element 6, and we've initialized a counter to check how many iterations it takes to reach the value. So when we run this code, we will get around, I think, 3 iterations, giving us the value 6 at the end. See, in the first iteration, z is assigned a value 5, and as it is not satisfying the required result, it moves on and assigns the value 7, which is also not the required one. So it moves on, and once it gets the value 6, it terminates the while loop and then comes and gives us the counter to be 3. So it takes 3 iterations to get to the number 6, and this is the implementation of a binary search algorithm using our programming language. So by this we wanted to say that real life problems can be implemented through this programming language, but there is a lot of scope to improve, and I think Tarun will explain the rest.
Yeah, hi. This is our main program actually. As Vikas discussed, we break down, we convert the given product to lexical, lexical analysis, we generate tokens and pass and generate pass tree. Now finally, we are here for a future implementation. Now the future implementation of programming language where we want to implement actually additional large data types such as long and double. We also want to provide input during runtime. We also wanted to include arrays and lists, and finally we want to implement functions. This is our future implementation. Thank you.